This is a recording for math analysis, and this is the beginning of section 2.2, polynomial functions. And our essential question is, can you graph and model real-world data with polynomial functions? And so write your level of understanding at the beginning of the lesson, and then we'll write it again at the end. And this is going to be a fairly short part, just because of what I'm anticipating for our time today in class. So pause this to write that, and then we'll move on. Okay, there is our vocabulary. I think we'll kind of go through that as we approach it. And so to begin with, polynomial functions is our first definition that we want to write down, and that is the sum and difference of monomial functions form polynomial functions. So polymany, I think that's what that means. Yes, it is. And so it has many terms. And we're getting to a point in our mathematics where we want to kind of be not missing out on things that we might have to see in our future. So if n is a non-negative integer, then a sub 0, a sub 1, a sub 2, dot, 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 to a sub n minus 1, a sub n are real numbers with a sub n not equal to 0, then the function is given by this. And I'm going to ask that you write that function down in function notation. So it's f of x equals a sub n, x to the nth, plus a sub n minus 1, x to the n minus 1, plus dot, 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 because it just goes on however long it has to, plus a sub 2x squared, plus a sub 1x, plus a sub 0. And, you know, in your mind, you can think about this as like a sub 0 times x to the 0, but since x to the 0 is equal to 1, we don't write that. So it always ends with a sub 0, a sub 1 is, and x to the first is just before it, then x squared and whatever. And so that's why this starts out as n. Maybe it's a sub 5, as to the 5th, then the 4th, then the 3rd, then the 2nd, and so on. But you want to, you know, in case you have to take more math classes in your life, you want to be familiar with that. So as you move along, that's something that you're used to seeing. And that is a polynomial function of degree n. So label that after you write it down as a polynomial function of degree n. The leading coefficient is the coefficient of the variable with the greatest exponent. So the leading coefficient in this case is a sub n. And so you do have to find the highest power of the variable, and then the coefficient in front of that is the leading coefficient, even if it's not written as the first thing that you see. So then you can see, here's just, you know, if you want to sketch these, go ahead. I don't think you really have to necessarily, but I will read through them. Constant functions, f of x equals c. So y equals 3, this one might be. And that has a degree 0 because it's like 3 times x to the 0. We don't write the x to the 0, oops, part there. Okay, just kidding. I'll erase it like this. A linear function, y equals ax plus c, we might be more familiar with y equals mx plus b. On this one, it looks like the intercept's 3, the slope is 1, so it's y equals 1x plus 3. The degree is 1, it's x to the first power. This is a parabola. I'm not even going to try to say what that function rule is, but y equals ax squared plus bx plus c, and that's degree 2. So we want to be able to give the degree, and we want to give the leading coefficient. So the 0 function is a constant function with no degree. And so there are some characteristics that things share here. And One is, oops, these are graphs of polynomial functions. So polynomial functions are defined and continuous for all real numbers and have smooth, rounded turns. So super important, smooth, rounded turns, excuse me. So is it going to be continuous or is it going to have discontinuity? Oh, it's going to be continuous because it has those rounded turns as you go along. So, you might even want to sketch something of that so that you can see. So that's an example. These are non-examples. Things that are not polynomial functions might have breaks, holes, gaps, or sharp corners. So look at that second one, or the one on the right, maybe it's an absolute value kind of thing. And so that is not a polynomial as we look at it. And we've seen discontinuous functions like this. We might also have discontinuous functions like that, which might be 1 over x, things like that. And some other things, if we have a graph of an even degree, it might look like x squared. If it has an odd degree, it might look like x to the third. We've talked about that end behavior and things like that, and even and odd and things like that that we've also learned in the last chapter as we've looked at things. So take your time, make sure that you get everything written down for these, and then we'll move on to problem number 1. And you can graph these on your graphing calculator, and maybe we'll just sketch them in our notes and then kind of say what we think is happening here. So here's problem number 1, and I might just plot some points just to be able to get it on this graph. It's f of x equals parentheses x minus 3 to the 5th. Put that in your calculator, see what it looks like. Okay, so I do have my graphing calculator now. So here is that rule. And I did make a table of values. So here's what I got for my table of values, just so it's easier for me to graph. And I looked at the picture of it as well. So here's kind of what it has for that graph. And I'm not going to get a whole lot of points on here, but I think I can get at least a few just to give me some marked points so that it's easy to see. I think at 2, I'm at -1, so I'll put that point on there. At 3, I'm at 0. At 4, I'm at 1. And then really, at 5 or at 1, I'm at -32, and then I'm at 32. So I'm not even going to cross that vertical line. So let me kind of just try to. Oh, and actually, if I remember right, it's kind of flat looking in there. And let me get that to kind of go. Oops. A little hard for me to draw, and you can see on the graph it's quite a bit flatter here than I quite have it, so it kind of goes steep and then it's kind of flat in there as we go. I just make it a little thicker to kind of see what's happened. And so when we kind of think about that, this is y equals x minus 3 to the 5th, or f of x equals x minus 3 to the 5th. And that minus 3 translates it to the translated right 3 as we look at that. And so that is what our graph looks like. And it has that, odd shape, which always kind of looks like this. So if we needed our end behavior, we could give that as well. So let's look at the next one here. And that is f of x f of x equals x to the 6th minus 1. Again, put it on your graphing calculator, and then we'll kind of compare and put it on our graph paper as well, because we do want nice little graphs of this. Okay, and so for this one, it's going to have that 6th power. So we're going to expect it to kind of have this type of shape, and that -1 is outside of the, parentheses, so to speak. It's not with that x, so it's going to go down 1. And if I look at my graphing calculator, I have the table of values there, so I'm ready to look at that. I have this in y equals x to the 6th minus 1. And if I look at that graph, here's what it is. Kind of looks like a parabola, very flat on the bottom, and then very steep as it goes. And so then I do have, I thought I had, oops. Oh, I think I wrote on this. And then let me see if I can paste that. There we go. It's a little big, but this is what we've got. So at -2, I'm at 63. That's way too high for me to go. At -1, I'm at 0. At 0, I'm at -1. And at 1, I'm back to 0. And then at 2, I'm at 63. And again, it comes down, is very flat looking, and then goes way very steeply increasing there. I have to say, I feel like that was my best one for that. Okay, then we're going to move on and describe some end behavior. And remember, we know some things about what happens in these problems. But before that, or to do that, we want to look at the leading term test for polynomial end behavior. So I'm going to ask that you pause this and write some good information about that, and then we'll move on. Maybe in class I'll kind of talk through that as we go. Now, moving on, if time allows, maybe you could take a few minutes and try to answer 2A. And I'm just going to leave that here at the end because I feel like we are going to have done a lot in class, and so I want to keep this recording kind of brief. And we may or may not go over this. I'll go over it in the next recording either way.